Hello and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we're going to be going over the derivatives of inverse trigonometric functions. So let's jump right in. So there are more or less three derivatives you need to know, sort of. But let me just prove the first one to you. So we already know the derivative of y is equal to like sine x. This is easy peasy stuff. But what if we need to find the derivative of y is equal to arc sine x, or sine to the negative 1 of x? How do we find that? Well, we can rewrite this as sine y is equal to x. Actually, let's make it arc sine x over a to make things a bit more interesting. So a sine y equals x. And then now we can implicitly differentiate this to get a result. So we have 1 is equal to a cosine y times dy over dx, since we have to multiply out the inside. So dy over dx is equal to 1 over a cosine y. And of course, cosine y is equal to the square root of 1 minus sine x squared. So this is more or less equal to 1 over a times 1 minus x squared over a squared, since b squared, yeah. And so what we can actually do is we can multiply both the top and bottom by the square root of a squared. So we get the square root of a squared is over a times the square root of a squared minus x squared. So we get, actually these two will just cancel out. So the derivative is simply 1 over the square root of a squared minus x squared. So this is the derivative of y equals arc sine x. And so similarly for, let me just note this down. So for y is equal to cosine negative 1x, we get the derivative as negative 1 over the square root of a squared minus x squared. And for y is equal to arc tan x, tan negative 1, we get the derivative is equal to, oh, not 1 negative 1, it's a over a squared plus x squared. So these are the three main ones we need to know. And yeah, so now we can jump into some questions regarding them. So the first one is find the derivatives of the following. I'm going to do the even ones actually. So we have to find the derivative of arc sine negative 1 to the negative 1 of 3 over 2x. So this isn't too hard. We can just chain rule this. We can say u is equal to 3 over 2x. And then this is dy over du times du over dx. So we know that dy over du in this case is equal to, actually, do we want to chain rule this or do we want to just apply it? Because, okay, never mind. You know what? Let's just do this. This is actually equal to x times 3 over 2, right? Which is equal to x divided by 2/3. So we have this, and then we can simply plug it into the formula, since we know dy over dx is equal to 1 over square root of a squared minus x squared. So we just have actually 4/9, because that's 2/3 squared minus x squared. So yeah, that should be the answer for this one. Sorry about that, I'm back. The book said I'm wrong, but this answer is actually correct. So yeah, I don't know what the book is doing. Anyways, let us move on to the next question, where we need to find the derivatives. And the first one is 2x times arc cosine to the negative 1 x. And so this is simply product rule. So we have first 2 cosine to the negative 1x plus, and then we have 2x times the derivative of cosine to the negative 1x, which is equal to negative 1 over 1 minus x squared. So this is actually equal to minus 2x over the square root of 1 minus x squared. So yeah, we can get that answer. And next, we have the question where we need to find the derivative of y is equal to x squared minus 1 times arctan 3x. And so again, we can apply product rule. So this is equal to derivative of this, 2x, arctan 3x, plus, and then we have to get the derivative of arctan 3x, which is equal to 3 over 9 plus x squared. So we have x squared minus 1 times 3. So we have 3x squared minus 3 over 9 plus x squared. So yeah, that should be the answer. Yep, apologies. This time the book didn't make an error in the working out, but actually in the formula they provided, this should only be 1 plus 9x squared, in fact. Actually, no, I think I made the error this time. So, my fault this time. Sorry about that. This should be the correct answer. And so finally, we have the last question, which is show why this is valid. Show why this is true. So d arctan x plus arctan negative x all over dx is equal to 0. I mean, this one's pretty obvious. This is just because this is equal to 1 over 1 plus x squared minus 1 over 1 plus x squared. So therefore it's equal to 0 because both inverse tangents correspond to the same angle in different quadrants, so the rate of change is effectively 0. So yeah, that is it for the speedrun, and I hope to see you in the next one.